Now in this video lecture, we'll continue our trigonometry. What we saw last time was if you have a triangle, what is sine, cosine, tangent, then cosecant, secant, and cotangent. And so we got the definition. So let's see now if you want to find out about sine, cosine, or tangent of various angles. Okay, so you should know the relationship between angles in degrees and radians, right? We know that we have 360 degrees, which is same as 2 pi radians. So if you, for example, want to find out 60 degrees is how many radians, right? So what you do is you say 2 pi over 360 times 60. So you cancel the degrees and degrees and you get the answer in radians. So this would be pi over, so 0, 0 cancels. This is 6. 3 pi over 3 radians is 60 degrees. 60 degrees is pi over 3 radians. And so on. You can get all the radians in terms of degrees and the other way around. If somebody gives you some radians, let's say r radians, how many degrees is that? So we put 360 over 2 pi times r. So radians and radians cancel and we get the answer in degrees. Okay, so that's one thing you must know. Now we need to derive the sine, cosine, and tangent for various angles. Now what you notice is, and we will see later on, that sine 9t minus theta is cosine theta. So for example, cosine of 0, let's say we know these values, sine values already, and we'll come back to that. Using those, we can get all the cosine values and tangent values. How? So we know if you put theta 0, I want to find out what is cos of 0. It is same as sine of 90. Sine of 90 is 1. So cos of 0 is same as this one. What about cosine of 30? If theta is 30, which is same as sine of 60. So sine of 60 is same as this. 45 is same as 45. And then these values are same like this. So in summary, what that means is, if you take this column and flip it about this center, so these values match, right? So this half is same as, these two values are the same. These values cross and these values cross. So by flipping the column for sine theta, you get the cosine theta. So once you have these two, say 0 half, 0 half, this is same as this, 1 square root 3 over 2, 1 square root 3 over 2. And tangent theta is sine over cosine. So 0 divided by 1 is 0. Half divided by square root of 3 over 2 is square root 3 of, is 1 over square root 3, which is same as square root 3 over 3. So half divided by square root 3 of 2 is same as multiply 2 on top and bottom. It is 1 over square root 3, which can be also written as square root 3 over 3. Then this one is square root 2 over 2 divided by square root 2 over 2. It's 1. So this divided by this is this. 1 divided by 0 is undefined, or you can say goes to infinity in the limit. We'll talk about that. What is a limit? Okay, that means if you can find the sine of these various angles, then you know the rest of the table. Cosine is a flipped version of that, and this divided by this gives you the next term for each one of these rows. So you can fill up the entire table. That means you will know sine, cosine, and tangent for all these angles. Now let's say for 45 degrees, you want to find out sine, cosine, and tangent. Okay. So if this is 45 degrees, this of course is 90, then this has to be 45 as well. So it's an isosceles triangle. These two sides are the same. So let's say if this length is 1, this length is 1. Now you can apply Pythagoras theorem. A square plus b square, 1 square plus 1 square should be c square. So c square is 1 square plus 1 square, which is 1 plus 1, 2. So what is this c length? Square root of 2. So the angle is 45. Hypotenuse is square root 2. then sine is 1 over square root 2. So sine of 45 is 1 over square root 2, which is also multiplying by square root 2 on top, and the bottom numerator denominator becomes square root 2 over 2, which is shown here. That is the sine. What about cosine? Adjacent over hypotenuse, so same as this. What about tangent? 1 over 1, which is 1. Okay, so you can easily derive sine, cosine, and tangent for a 45 degrees angle. What about 30 degree angle? Okay, so let's take a triangle, 30 degrees. This is 90, which means this is 60. Now, if you take a mirror image of this triangle and put it here, so what do we get? We get 90 degrees here, 30 degrees here, and 60 degrees here. Now, if you look at this outside triangle, this triangle, what you see is the three angles are all 60. So it's an equilateral triangle. All three sides are the same. So let's take this to be 2. Okay, that means this is 2. So which means this length will be 1. So now let's get back to our 30 degrees original triangle. So we know this length, hypotenuse is 2, opposite is 1. So again, a square, let's call it a. So Pythagoras theorem says a square plus 1 square equals 2 square, which is 4. So a square is 4 minus 1, 3. So a is square root of 3. So this becomes square root of 3. So once we have that, we can find sine of 30, which is opposite over hypotenuse, 1 over 2. So sine of 30 is 1 over 2. What is the cosine? Square root 3 over 2. And tangent, 1 over square root 3, which is also square root 3 over 3. And if you want to find for 60 degrees, look at here. If it is 60 degrees, its adjacent is square root 3. Its adjacent is 1. Opposite is square root 3. And hypotenuse is 2. That means sine of 60 would be square root 3 over 2. Square root 3 over 2. This over this. Cosine of 60 would be opposite 1 over 2. 1 over 2. And the tangent is square root 3 divided by 1, because this is the angle we are looking this way. So that means we have covered 30 degrees, 45 degrees, and 60 degrees. Now, 0 and 90 degrees also you can derive. So if you can look at a triangle like this, right? This is adjacent, opposite, hypotenuse. Now sine theta is given by O over H. Now when you make angle theta equal to 0, what happens is A and H become the same, because this is coming down. See, when the angle is 0 degrees, our H is A, and our opposite is, in fact, his length is equal to 0. So this is O and this is 0. So sine of 0 is opposite over H. Opposite 0 over H, so it is equal to 0. So sine of 0 is 0. Cosine is adjacent over H, but A is equal to H, so it becomes 1. And tangent is just 0 divided by 1. Okay, or the opposite, which is 0 divided by A, which is still 0. And for 90 degrees, again, if theta is this, for 90 degrees, we keep moving this point closer, like this, like this. The angle is increasing, increasing. So in the case the hypotenuse is equal to the opposite, that is the situation for the angle equal to 90 degrees, and the adjacent is equal to 0. So therefore sine of 90 is equal to opposite, which is same as H, divided by hypotenuse. But O is equal to H. This is H over H is equal to 1. So sine of 90 is equal to 1. Cosine is adjacent over hypotenuse. Adjacent is 0, so this is 0. And tangent is the height divided by 0 length. So it's divided by 0. So it's undefined, or you can say it's to positive infinity. So this finishes deriving the entire table. And another way to remember the table, so you can of course derive all of these three for each of the angles as we just did. Or we can say, let's make this column first. The column is obtained as follows. We do square root of 4 over 4 over 4 over 4. And then put 0, 1, 2, and 3. Square root of 0 over 4 is 0. Square root of 1 over square root of 4 is 1 over 2. This is 1 over square root 2 or square root 2 of 2. And this is square root 3 over 2. And you can see very clearly these are sine of 0, sine of 30, sine of 45, sine of 60, and finally, I forgot the last one, which is square root of 4 over 4, which is 1. And that is this one. So these, square root of 0 over 4, 1 over 4, 2 over 4, 3 over 4, these are sines 0, 30, 45, 60, and 90. Once you have these values filled up, you flip this column, you get this one upside down, and then this divided by this gives you tangent. But we can also prove all of them, as we just did. Okay, so in the next lecture, we'll look at these fundamental identities.